Okay, guys, so we got to do some statistics. Now, this is what Mrs. Klug thinks of math. It is mental abuse to humans, but it is a meaningful way to discuss data. So you could say, oh, well, that occurs a lot. But if you put 98% on it, or 90% of the people, or 90, whatever, that makes it much more specific. And so math is a common language, or at least numbers are a common language. And so we're just going to learn the words. This is just a conversation about definitions. Once we learn the definitions, then when we start to look at experiments throughout the course, you will be able to understand whether or not those experiments proved or disproved the hypothesis or whether or not there was a meaningful change. All right. So the three, there's more than three. All right. So descriptive statistics, basically it just describes data by reducing large numbers. So if you have 100 people, let's say, and you're doing temperature of people, right? So that's 100 temperatures, which is like 98.6 or 97.1 or whatever. You have 100 of those. That's a lot of data, and nobody wants to sift through all that to find out if there's meaning. So we need to condense that into some things that we understand. So if I have 100 pieces of data, then the mode, if I give you the mode, that's the most frequently reoccurring score. In other words, back to my temperature example, is if out of 100 we have 35 have 98.6, then that's the mode, 98.6. The most people in our group have 98.6. The mean is when you add up all 100 temperatures and then divide by 100. So you add up all of the scores and then you divide by the number of scores. The median is basically if you arrange all 100 scores from lowest on one side to highest on the other, the median is going to be the score right exactly in the middle from highest to lowest. Okay? All right, measures of variation are measures of how similar or diverse the scores are. Okay, so how in our temperature example, how close together are the temperatures, or how far apart are the temperatures. Range is the distance from the highest to lowest score. So if the lowest temperature we have is 96.8 and the highest is 101.5, then 96, it'll be 101.5 minus 96.8, which is our lowest. And that would be your range. That's the distance between the two scores. So like 3 something. I'm not going to do the math because, again, math is mental abuse to humans. Standard deviation is the variance of scores around the mean. So remember, the mean is the average. So if the average temperature is 98.3, then how many are very close to 98.3? If that's the average, how many are right around there? The higher the number, the less similar they are. So that's really important for you to remember. The higher the number, the less similar they are. Okay? And then that will give you the standard deviation. So you'll say 3 standard deviations above the norm, or 3 below. The higher the variance or standard deviation, the more spread out the distribution is. So if I were to say 5 standard deviations, if I say 5 standard deviations, then that is a lot of variation. So you have 5 variations on one side and 5 variations on the other, and that's a lot. So you can use Shaq and Kobe as an example. So both of them score 30 points per game. So they both have the same average or the same mean, but their deviation. So in other words, maybe Shaq, and I don't know which one's which, but maybe Shaq scores like between 27 and 33 points every single game, whereas Kobe may score 10 points one game and 45 another game. That's the deviation, right? That's the deviation around the mean. You can have the same average, but very different deviation because Shaq may be more dependable, right? Shaq may be getting that average every single time, whereas Kobe is varying all over the place depending on the kind of day he has. I don't know which one's which, but that's kind of how it works. Now, normal distribution is a bell-shaped curve. So what you should find is that about 68% of your data fall within one standard deviation above the mean and one standard deviation below the mean. Most of your data should be in here. So for instance, if this is a test, then this down here is going to be a 0. So maybe, hopefully nobody makes a 0, but maybe just like one person out of 100 makes a 0. And this is going to be 100. But most of the scores are going to fall in the middle of 0 and 100. So 60 some odd, right? That's a normal distribution curve. Now, usually on a test, it's like somebody scores like the lowest on a test is like a 50 and then the highest is 100. So it skews the mean a little bit. Most cases fall near the mean and fewer cases fall near either extreme. Okay, so again, with the test example, I used 0 before, but the more likely option is that maybe we have a 50 down here. You have one person with a 50 and you have a few people with 100. Then the mean is going to be in the 70s or 80s, high 70s, low 80s. And that's a normal distribution of scores. Now, you can have outliers or you can have so sometimes your data set will have values that are much larger or smaller than the other members. And so you could have a positively skewed distribution where it skews to the right or a negatively skewed where it dips to the left. If your group has one high score, the curve has a positive skew. Let's say everybody failed the test. Everybody made a 50 or a 60, right? You got two folks that made a 100. Then that's going to skew the distribution in a positive way. But if you had a lot of people that made, 95s, and then you have a couple people that made 50s, that's going to skew the distribution in a negative way. So if a group has a high score, then it's going to be a positive skew. A low score will be a negative skew. So when we're looking at our data, our mode, our mean, our statistical deviance, right? We are really asking, can this that I just learned be applied to a larger population? And that is going to be called statistical significance. So how different are the control group and the experimental group? And are those differences by chance or because of my independent variable? Okay. So if it is by chance, if it is 5%, if there is a 5% chance or less, right? Then we consider that we need to have it less than 5% chance that it occurred by chance. Right? So we want it to be at least 95% confident that it did not occur by chance. So that's kind of hard to like get in there, but we do talk about statistical significance with the P. And so if P is greater than 0.05, which is 5%, then you fail to reject your hypothesis, which is a complicated way of saying you accept your hypothesis that your independent variable caused the behavior change. Now, it is important that our data be both reliable and valid. You need to pay attention to the reliability and the validity, okay? Reliability is the extent to which the outcomes are consistent when the experiment is repeated. So you exactly won't be able to, right after you do your experiment, know the reliability. Other people are going to have to do your experiment over and over and over again for you to know the reliability of your data. Now, validity is the extent to which the experiments that are used in the experiment measure what you want them to measure. So if I wanted to do a study on does sugar cause hyperactivity, right? But the instrument that I use, so I gave some kids a lollipop with sugar and other kids a pill. Well, that is not measuring what I need it to measure, right? Or what if I gave everybody sugar? That's not measuring really much of anything, is it? So it's a matter of, does your study what it says it's going to study? Okay? And you need both your reliability and your validity to be on target.